At this time, I'd like to place the natural numbers on a number line. Let's recall what the natural numbers are. They're the counting numbers 1, 2, 3, 4, 5, and so on. In order to place the numbers on the line, we just need to put dots on the corresponding hash marks. There should be a dot directly on the 1, and a dot on the 2, a dot on the 3, and so on. This pattern will repeat forever, so we'll put ... next to it. Finally, I'll surround the natural numbers with some braces, and that represents the natural number set. So both the picture and listing the elements in roster form are two different ways of representing the natural numbers. The next type of diagram I'd like to draw is called a Venn diagram. With a Venn diagram, we can represent sets as enclosed in bubbles. Here's a bubble that represents the natural numbers. Look at the list down below and pick out any numbers in that list that are natural numbers. Place any natural numbers inside the natural number bubble. The numbers on this list which are natural are 1, 2, and 3. So we want to write those inside the natural number bubble. Sometime after the discovery of the natural numbers, humans realized that there was one number that wasn't on the list, but it should be. And so the whole number set includes everything that the natural numbers has, and more. What number do you think it was that got added? The number that got added was the number 0. And I'll call that the whole number set. Since the whole numbers has everything that the naturals has and more, we want to draw a bigger bubble. And every natural number is part of the whole number set. And that's why the naturals is contained inside the wholes. However, where does the 0 go? The 0 can't go inside the natural number bubble because it wasn't discovered at the time the naturals were. The 0 needs to go outside the natural bubble. It was a later discovery. But should it go so far outside that it is way out here? No. 0 is a whole number. If it was out here, that would show that it wasn't whole. We need it to be outside the natural bubble, but we still need it to be inside the whole bubble. So where does it really go? It goes here. The integer set was a more advanced discovery. It has everything that the whole numbers has, and more. With integers, people realized there was a difference between having something and owing something. So what do you think was discovered? Negative numbers. They go on forever in the negative direction and the positive direction. But notice these numbers are still directly on the hash marks. There aren't any fractions or decimals that are off of those hash marks. If we surround these numbers in braces, we'll call this the integer set. And it has the symbol big Z. So we need a bubble for it. Notice that with each development, humans' understanding of numbers is becoming better and better. And we're expanding on our knowledge, building outwards from what we had. And so our Venn diagram needs to reflect that too. We need another bubble. And this is going to be the integer bubble. Look through the list and see if you can find any numbers that aren't natural and aren't whole, but they are integers, and therefore they should go in the outer ring. -3, -2, and -1. Finally, that brings us to the real numbers. The real numbers have everything that the integers has and more. What else is there? Decimals and fractions. The real numbers are everywhere on the number line. And this brings up an important difference in mathematics between the term discrete and the term continuous. With the integer set, only certain values were allowed. You couldn't have decimals and fractions that weren't on the hash marks. But the real numbers are everywhere. And so, the integers is what is called a discrete number set. And the real numbers is continuous. It's an important distinction in mathematics because whereas computers and electronics, logic, and some finance math are based on discrete concepts, things like physics and calculus are based on continuous concepts. It's impossible to make a list of the real numbers. And interestingly, in between any two real numbers is an infinite number of other real numbers. Think about that. Even just between the numbers 0 and 1, there are an infinite number of numbers. It's hard to imagine. The real numbers do have a set name. It's big R. Finally, we'll make a real number bubble. It goes around all the other bubbles because it contains all of them. However, in that outer ring, there will be some real numbers we can put that don't belong in the other three sets. These would be any fractions or decimals that aren't integers. Look through the list of numbers at the bottom and see if you see any numbers that should go in the outer ring. These numbers belong in the outer ring. They're not naturals, and they're not wholes. They're also not integers. But they are real, so they belong in the outer ring. Is there a number that would go outside the real bubble? That's an interesting question to consider. It would not be real. And there is one that I can put out there that we'll see in a future video. It's the imaginary number, I. It can't go inside the real bubble because it's not real. It's imaginary. Try this question and see if you can identify the correct way to write each number set. The correct answers were A, G, I, and K. Let's look at some different types of Venn diagrams. This question is about age categories. Each person in a group is going to choose exactly one box below. They'll either pick under 21 or 21 plus. Assume no one in the group abstains and no one chooses more than one box. I'll make up some example data. Let's say we have 6 people and their ages are 18, 19, 20, 21, 25, and 30. Person who's 21 will check the 21 plus box. And they won't check the under 21 box. So draw a Venn diagram depicting these different age categories. What features are important in such a diagram? In this situation, we don't want the bubbles to be nested like they were in my previous Venn diagram. We want them to be separate bubbles. Let's label the bubbles. Now we can place each person into the category and set that they belong to. The 18-year-old belongs in the under 21 bubble. So does the 19-year-old and the 20-year-old. In the 21 plus bubble, we'll have the 21-year-old, 25-year-old, and the 30-year-old. Notice that it is impossible for one person to belong to both sets. Nobody is both under 21 and 21 plus in the same instant of time. These bubbles are separate and there's no need for them to overlap. Under 21 and 21 plus are called mutually exclusive, meaning they can have no elements in common, and it is impossible for one person to belong to both groups simultaneously. Now let's try one more type of Venn diagram. Assume a group of people are to be categorized by their feelings toward animals, and they'll check any box that applies to them. The boxes are cat person, dog person, both, and neither. Draw a Venn diagram. What features are important in a diagram that portrays this situation? I hope that for this Venn diagram, you drew overlapping bubbles. Where one of the bubbles is a cat bubble and the other a dog bubble. But it is possible for a person to be both. If a person doesn't check the cat box or the dog box or both, then they'll check the neither box. But even they belong to something. And so that leads us to what is called the universe set. The universe set, by definition, includes everything under consideration in the problem, even those who check neither. Now I'll give you some results from the survey and see if you can place the people into the correct category. Let's say that 2 people checked the cat box. 3 people checked dog. 1 person checked both, and 2 checked neither. Can you place dots inside the bubbles to represent these people who took the survey? I'll do one for you. One person said both, so they should be represented as a dot that falls in the middle. Place the other dots in the diagram, and we'll see if your answers match mine. Okay, so this exercise usually gets a lot of varied answers, and they're not all mathematically logical. And so we want to make them mathematically logical, or at least bring up the issues for why you may have done it differently than another person did. So one thing about the wording here is it didn't say cat only, and it didn't say dog only. It just said, are you a cat person? In other words, do you like cats? The cat only region would be over here. This means you like cat, but you don't like dog. Similarly, over here is the dog only region. This means you like dogs, but you don't like cats. If you're in the dog only region, you are in this section. If you're in the cat only region, you're over here. So I'm going to start with those who checked neither, because I feel like that's the easiest one to start with here. If you checked neither, you're outside the cat and dog bubbles, but you're still in the universe set. Now, the tough question is, how many dots go in the cat only region? I would put 1 dot in the cat only region. This way we have a total of 2 dots that are really within the cat bubble. And so it's correct. I'll place 2 dots in the dog only region, because now we have 3 total dots inside the dog bubble. So it's true that 3 people like dog and 2 people like cat. One of them likes both and 2 of them likes neither. So the question is, if you had checked the box for both, should you also check the box for cat and dog? And the mathematical answer, according to the Venn diagram logic, is yes, you have to. The one person who checked both is in the middle. That means they are inside the cat bubble, so they have to also check that they are cat people. And they're also inside the dog bubble, so they have to check that they're dog people too. That's the meaning of being both. In this example, assume any given time is going to be classified as either night or not night. And the weather will be classified as either raining or not raining. According to the Venn diagram, what are the time of day and weather conditions depicted by each area below? If we're in region A, we're inside the night bubble, but outside the rain bubble. So it's night and not raining. If we're in region B, it is night and raining. In region C, it is raining, but not night. And in region D, it is not raining and not night. Take a look at this Venn diagram. U stands for the universe set. List all the elements of each set in roster form. Elements of set B are 2, 4, and 6. The universe set contains everything in the problem. Notice that the bubbles for sets A and B don't overlap. Which choices below are correct? The correct answers were: members of B are not members of A, and members of A are not members of B. This is because the bubbles are distinct, so it's impossible for them to share elements in common. Another way of saying this is no A's are B's. Let's say that set A contains the positive factors of 6, and set B contains the positive factors of 8. And there are some other elements that are part of the universe set as well. List the members of each set in roster form. A contains the elements 1, 2, 3, and 6. 1 and 2 are counted as part of set A because they are technically inside the A bubble. The A bubble is this. Any member who falls inside that region is part of the set. This is the B bubble. What elements are inside the B bubble? 1, 2, 4, and 8. Now list the members of the universe set. There are 1, 2, 3, 4, 5, 6, 7, and 8. Which statements below are true? The correct statements were A, B, C, E, F, and G. Now let's consider some sets that could contain some huge numbers of elements, such as the set of football players and set of athletes. Notice that the football bubble is contained within the athlete bubble, and that has meaning here. Select any statements below that are true. The correct choices were D, E, and H. If a person is a football player, then that person is an athlete. If a person is not an athlete, then that person is not a football player. All football players are athletes.